Okay, so we're picking up with question 51. It says, what is the molecular formula for this compound? So first of all, let's figure out what we have. We have C3, and then we have H, 1, 2, 3, 4, 5, 6. And so we are not going to simplify that down. We're just going to write that as is because they're not asking for empirical. What's the chemical formula for sodium oxalate? So sodium is Na with a +1 charge. Don't believe me? Go to periodic table. Oxalate is a polyatomic. So that's on table E. Sorry. Oxalate is C2O4 minus 2. So C2, whoa, cat, C2O4 minus 2. Which means you crisscross and you get Na2C2O4, which is choice D. Iron, Roman numeral 2 oxide means iron plus 2. O is minus 2. That is found on periodic table. You don't need to crisscross because it's already neutral, so it is choice A. Ammonium sulfide. Ammonium is NH4 plus 1. Those are my cats going crazy. That's on table E, and sulfide is just an S, minus 2. So you'd have NH4 in parentheses 2 with an S. Choice A. What is the chemical name for this? Okay, so we have the functional group C double bonded O, and then this N here. So going to table R with the C double bonded O and an N, that is an amide. So parent chain plus amide is how we name it. So meth-eth-prop-bute, that's on table P. So butanamide. So choice C. These cats are absolutely nuts. Guys, what's the chemical name for NH4SCN? So we're going to go to table E. NH4SCN. NH4, ammonium, SCN, thiocyanate. And we don't change names at all. Ammonium thiocyanate. Okay, empirical formula for butene. So we need table P and Q. So bute is 4. Ene means double bond. So we would double the number of carbons, number of hydrogens. So C4H8. And you'll be tempted to take that as your formula, but since it asked it for an empirical, we want the simplest form, so that would be choice A. 3 kinds of formulas. We want empirical, we want structural, and we want molecular. Gram formula mass. Okay, so gram formula mass, we've got these for the next 2. You go and you find the masses on the periodic table. So calcium, oxygen, hydrogen. So calcium is 40. There's only one of them. Oxygen is 16, but there are 2 of them. So it's going to be 32. Hydrogen is 1, but there's 2 of them. So 2. And then you add those up. So 40 plus 32 is 72, plus another 2 is 74. FeNO3 taken 3 times. So this is going to be 3 times 14. This is going to be 9 times 16, and whatever iron is. I got to look that up. I do not know. Iron. 56. Yes. 56. Whoops. 56. Okay, I'm getting my calculator out. So 9 times 16 is 144. 14 times 3 is 42 and 56. So 144 and 56. 242 grams per mole. All right, so this one looks harder than it actually is. It says, given the balanced equation representing a reaction, and so it is, if 46 grams of Na and 71 grams of Cl2 react. It's the total mass. You don't do stoichiometry, you simply add them. 46 plus 71 gives you 117 grams. It's just the law of conservation of mass, which is a mole of atoms. So remember, 1 mole is equal to 22.4 liters. None of those work. It's also equal to Avogadro's number, 6.02 times 10 to the 23rd particles. It's also equal to the gram formula mass. So it's essentially saying which of the following is coordinating with its correct mass. So we need to figure out, well, first of all, I know the mass of carbon is 12, so that's not it. So we need to figure out sodium, krypton, and potassium. So sodium's mass is 23. So, I mean, I remember that was a choice. So that's the answer. Whoops. Whoa. And if you wanted to prove the other ones are wrong, you just go and you'd see that these are not the masses on periodic table. The number of moles of molecules in a 12-gram sample of Cl2 is. So we want to go from grams to moles. So we're going to divide by GFM. Cl is 35, but it's Cl2, so it's 71. So 12 divided by 71. Which type of reaction? Okay, so first of all, these are organics. Take a look. We've got C4H10 and we've got a Cl2. On the other side, it looks like one of the Cl's has jumped in here and one of the H's has come out. It's called a substitution reaction. What kind of reaction is happening here? So it looks like we're combining things together and energy is being released. Decomposition breaks apart. Double replacement needs 2 compounds. Single replacement needs a singleton and a compound. Synthesis is when they come together. Given the key, chemical change makes bonds, breaks bonds. A is simply bringing things together. B is simply bringing things apart. C is simply switching things around. D is actually breaking bonds and making new ones. What is the vapor pressure of propanone at 50 degrees Celsius? So it's reference table H. Propanone at 50. So here's 50. Propanone is the first. So that's 50, 60, 70, 80 kilopascals. That's not a choice, so I go with whatever's closest. 83 is right. Why is Br2 a liquid and I2 is a solid at STP? Well, it has to do with intermolecular attractions, not polarity. If you are a liquid, you are held close together, but not super close. A solid is very, very close. If we were going to look back here, A is like a liquid, and this is a solid. So the iodine solid has stronger intermolecular forces holding them together. Okay, so once again, the strongest intermolecular forces are going to take the longest to boil, thus have the highest boiling point. So which of the following has the highest boiling point? Hydrogen fluoride, choice A. Molecule ion has to do in a solution. So you want the aqueous, because aqueous means dissolved in water. So right here we have the molecule, right here we have the ions. Components of a mixture. When you make a mixture, each component gains new properties. No. Each component loses properties. No. The proportions can vary or cannot vary. Well, I can have saline or salt water. I can have it straight from the ocean, and I can also have it from my contacts. So they can vary. Salt water. Which statement describes a mixture of sand and water at room temperature? So in sand and water, when you mix them up, you can still see their differences. So it's heterogeneous and the components are in the same phase. Well, no, solids for sand and water is liquid, so it's got to be B for 72. Differences in which property allow the separation of sand and seawater by filtration? How about particle size? Sand is big particles that will not dissolve. Salt is small particles that will dissolve. So 73 is D. Equal amounts of ethanol and water. So ethanol is an alcohol. and water, and they're mixed at room temperature, standard pressure. Which is the process used to separate them? It is called distillation. Distillation is the process to separate liquids, and usually they do use alcohol and water based on boiling points. Petroleum can be separated by distillation because hydrocarbons in petroleum are they elements and are they compounds? And talk about boiling point. Well, first of all, they have to have different boiling points because that's how it works. But petroleum is a compound, so it's got to be choice D. Petroleum is hydrocarbons. Paper, chromatography can separate components of a mixture because of different decay modes. We're not talking about anything radioactive. Thermal conductivity, that has to do with heat? No. Ionization, gaining or losing electrons? No. It's polarity. Because if likes dissolve likes, they're going to come together. If they do not have the same polarity, they're going to try to move away from each other. And that's how it works. A substance is anything with a formula, so element or compound. So air does not have a chemical formula, so that's not it. Ammonia does. It's NH3. There's your answer. According to table G, which substance forms an unsaturated solution when 80 grams of the substance are stirred into blah, 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 blah. Okay, so let's go to table G. And it's HG. Okay. So KNO3 at 10 degrees. Whoops, I went beyond. Whoops. KNO3 at 10. That's now eraser. KNO3 at 10. Try it again. Okay, so that's like 24, etc. I can't, yeah, 23. And hold on a second. Let me read the question. Which substance forms an unsaturated 80 grams? Oh, I forgot. It told me how many grams there are. Whoops. 80 grams is here. So here's the point. Okay, so there's the point in comparison with my curve. See how this point is above the curve? That means it's supersaturated, so it can't be that. Ki is here. The point is below, so that's why it's unsaturated. So that's got to be my choice. Let's just keep going. NH3 is here. Notice how the point is above that curve, so that'd be supersaturated. And NaCl is here. The point's above it, so it's got to be Ki. Yeah. A beaker contains dilute sodium chloride solution. What happens to this number of solute particles in the solution and the boiling point of the solution as more are dissolved? So you're adding more solute, the number of particles will increase. Now, as you increase the number of particles, the boiling point is higher and the freezing point is lower. So it's increase for 79. Based on table F, which is least soluble in water. So they're asking for who is insoluble. So let's take a look at table F. Phosphate is insoluble except with group 1. And aluminum is not in group 1, so that's got to be our answer. Let's just keep going, though. Sulfate is here. It is soluble, except with all these. So lithium is not an exception, so that's soluble, which is not what we want. Hydroxide is insoluble, except with all these, including calcium, so that's out. And acetate is always soluble, so we wanted aluminum phosphate because that is insoluble. Choice 1, or A. A solute is added to water and a portion of the solute remains undissolved. When equilibrium is reached, that is called saturation. A unsaturated solution is formed when 80 grams of salt dissolved 100 grams of water at 40. This salt could be. So we're looking to see which of the following apply. So let's go back here. I have to erase all this. Okay, so it says 80 grams of salt at 40. So 40 and 80 is right here. So we want this to be under the curve. So KCl is here. That point is above the curve. Nope. KNO3 is here. That point's above the curve. Nope. NaCl is there above the curve. Nope. NaNO3 is here. Oh, the point is below the curve, which means it would be unsaturated. So it has to be choice D for 82. What is the concentration of an aqueous solution that contains... Okay, so this is molarity. So the formula for molarity is here. Whoops. Molarity. Moles of solute over liters of solution. So if I come over here, moles of solute over liters of solution. Oh no, I have milliliters of solution. So I'm going to need to move this to 0.5 liters. So 1.5 divided by 0.5 gives me 3 molar. What is the molarity of 1.5 liters of an aqueous solution that contains 52 grams of lithium fluoride? But it does give me the GFM. So remember, it's moles of solute, not grams. So how do you go from grams to moles? We divide by GFM. So 52 divided by 26 is 2 moles. Divided by 1.5. And you get 1.3 repeating. There you go. 84 should be A. What is the total number of grams needed to make? Okay, blah, blah, blah. So we're going to go backwards. So molarity, put it over 1, equals moles of solute over liters of solution. So that's going to be 0.010 moles times GFM. NaI. So we need the masses of Na and I. So Na is 23. See this right here? And I 127. So that's a mass of 150. So 150 times 0.01. 1.5 is that. By the way, if I'm going too fast in these videos, please make sure you talk to me in person. Parts per million for number 86. This formula is here. Whoa. It's a concentration. Mass of solute over mass of solution. But we're multiplying by 1,000,000. So mass of solute is 0.12 divided by 2,400 times, and it's 1,000,000. So 0.012 divided by 2,400 times 1 with 6 zeros is 5. So when we talk about colligative properties, which are adding a solute to water, you're going to have higher highs and lower lows. So compare the boiling point and freezing point of 100 grams of pure water compared to a solution where you dissolve things. So lower lows would be lower freezing point, but higher highs, higher boiling point. What does a catalyst do? It's a shortcut. It gets you there faster. So it's a different reaction pathway, which gives you a different PE of products. No. Different reactant. No. It's activation energy, less energy. Shortcut. Chemical reaction occurs when reactant particles have proper energy and orientation. If you're going to punch a window, you have to first aim your arm towards the window to have proper orientation, and you need to punch it with enough force to actually break that window. Otherwise, it's not going to work. PE diagram, where's the heat of the reaction? That's the difference of PE of products minus PE of reactants. So here's the PE of products. Here's the PE of the reactants. So the difference between those two is 2. In most aqueous reactions, as the temperature increases, the effect of collisions will also increase because as things are moving more, they're going to keep bouncing around more. Which is going to increase the rate of reaction. Increased surface area means more contact with the solute, with the solvent, excuse me, and you want a higher concentration of HCl because it will be greater moles doing some work here. Hydrochloric acid reacts with powdered zinc with an equal measure. So the greater surface area of the powdered zinc increases the frequency of particle collisions. Yes, more opportunity to interact. Catalyst increases the rate of reaction by providing an alternate reaction pathway, lowering activation energy, not increasing. Not increasing. Potential energy direct exothermic. So first of all, it's got to be curvy. In an exothermic reaction, heat is given off, so it's choice D, showing how we start high and then ending low. The difference between PE of products and PE of reactants is called the heat of reaction. What's the amount of heat released by 1 gram of liquid water at 0 when it changes to 1 gram of ice? Okay, so we've got the 3 heat formulas. Q equals MC delta T, MHF, and MHV. So this is when we have a change in temperature, which we don't. This is between a solid and a liquid, and this is between a liquid and a gas. So I believe it was at 0 degrees. So it's going to be Q equals MHF. We need the heat, we need the heat of fusion constant for water, which is 334 joules per gram. So we're going to say 1 is the mass, 334 is the constant, so number 97 is C. Where's the activation energy for the reverse? So first of all, reverse starts here, ends here. So this is the activation energy of the reverse. So this chunk right here is C, this chunk right here is B, so it's got to be that one. At equilibrium, requal, con. The mass, no. Entropy, no. Rate of formation must equal the rate, yes. Requal. Finally, at solution at equilibrium must be saturated, so the rate of dissolving must equal the rate of precipitation. All right, that's going to end part 2, questions through 100. If you've got any questions, please see me. Thanks.